Welcome to Saturday Morning Tonic. This is T-Formula, broadcasting live across the world. Late night New Zealand and morning time in the UK. Even earlier morning in the US. Today is session 4. As you can see, we have 75 days to go. Well, that jumped down, didn't it? So time's going quickly. Watch out. We're going through area and volume today. So we're looking at circumference, area, circle, sectors, trapezium or trapezii, volume of prisms, cylinders, pyramids, cones and spheres. So there's lots to get through. I'm not going to do them all in massive detail, but they all will at least show themselves. And let's get on with it. Don't forget, if you want a pre-release of these questions in advance to have a go, that is the best way to access this content. And you can find that on my Patreon, patreon.com/tformula, where I'm giving these away for absolutely free. Don't be scared to go and grab it. If anyone is having a trouble getting it from there, please let me know. I could find a different way of putting them somewhere, but at the moment, that's the way I get them. It's like an online store. So do it in advance and then come here for the answers. That's definitely the best way. Do it yourself. Looking at the videos and how someone does it, it's only part of it. You need to be able to go through that journey yourself. So patreon.com, and there's a whole host of other stuff there as well. So hope to see you on the other side. Let's go. So there's a few things we need to know with circles. All right. So we need to know that the the area and the circumference of a circle is. So we can write that at the top here. So area, in fact it might want to be on pen mode, otherwise nothing's happening. I'm going to get my watch off so it's not in the way, and here we go. Area is equal to pi times r squared. I think at this level we don't need to talk about what pi is. Pi is a constant, it's a number, and r is the variable. So we need to know r in order to use this. Sometimes we have a, the area, and we want to go backwards and we want to find r. So circumference all the way around the outside is equal to pi again, multiplied by the diameter, which is also, if you had just the radius, then 2 lots of the radius is diameter. So you can see that formula as 2r times pi rather than d times pi. All right, basics out of the way. A wire is bent into shape as below with 2 equal circles in the center. And then we've got that one around the outside. So that's all one wire. And if we unravel the wire, how long is it? So essentially looking to find the circumference of all those circles present. So we could say the circumference of the large circle is equal to pi times its diameter there, which is 4. And we often write the number in front. The circumference of the smaller circle, well, first of all, we need to realize this is going to split down the middle. So it has a diameter there of 2 centimeters, and both of them do. So each one is going to be pi times diameter, which is 2 pi. So these are actual numbers, and if you put them in a calculator, sometimes you see what they are better, because pi is, pi. If you want to see what they are, you have to press this button here, because the answer itself will be it'll give you 4 pi. So you press the S to D button and it will change it from this to a decimal, which is approximately 12.566. Now, both of these answers are fine, but as you can see, the extra step was finding the decimal. So we don't actually need we want to save time, so we don't need to do it that way. So I'm going to stick with pi, but just to give you an idea, what these are as a rough size, we've got 6.28, that's half of the other one. So these are roughly, they're numbers, if you want to think about it that way. I'm going to get rid of that because it's much neater to use it in what we call exact form. And this is exact because pi, as you know, goes on forever. So it's like 3.141, etc., etc. As soon as we stop it from going on forever and we round it to whatever decimal places, it's obviously not the same. It's less. And so using the exact form is a really neat and elegant way. It's also quite straightforward. Now we've got one of those circumferences. We actually want two lots of the small circumference, which is 4 pi. We want two lots of them because there's two of them. Now we're going to add them all together. 4 pi at the top there for the large one, plus two lots of the small one, and the total length of the wire is going to be 8 pi, and it's in centimeters. Now if that looks really odd and weird, then you could look at it as 8 times pi and then write it the decimal. In other words, that's 25.1327 centimeters. You can, not squared, you can round that if you want, so 25.13 to 2 decimal places. Okay, so if you prefer decimals, that gives you an idea of the size, but as you can see, it's always extra. A £2 piece has the, let me scroll down with the mouse. A £2 piece has the dimensions as shown. What is the area of the brass section if the radius of the center circle is 10.5 millimeters? Okay, so we've got a little bit of diagram work to do here. So the brass section is around the outside. Okay, so just to make it clear, it's this bit that goes around the outside. And the radius of the center circle is 10.65. So if we go from the center to that first line, that's 10.65. Now, I don't know if that's too clear, but it's roughly, we've roughly got it. And so there's a couple of things to do here. My plan would be to do the large circle, and I'm going to take away the inside circle. So we can call that the large one, and we could call this one the inside circle. And that will leave me with the brass, because that's what we're after, the area of the brass. Let's underline that. So we're after the area of the brass section. Okay, so let's do it. That's our plan, so let's leave it there. We can refer back to it. Our first mission is to find the area of the total, and we can do that based on this. So we know that the area of the large is equal to pi times r squared, which is 28.4 over 2. Let's just put it here, 14.2. We'll do that in our head, squared. So calculator job, do the 14.2 squared first. There's a little button where you can use the squared, and then multiply that by pi. You get pi by pressing the little shift button in the top left, and then there's a pi button at the bottom. It really depends on your calculator, but definitely find where pi is. It will be used a lot. So we can leave this in terms of pi. Your calculator will usually give you a fraction of pi, like this, and this is like the easiest way if you're going to go back and use this. But if you're a decimal fan, that's 633.4707. We probably want to put as many decimal places as we can be bothered, so that we don't lose the accuracy. And this was originally in millimeters, so it's millimeters squared. It's now an area. I think this is very odd. It looks like a lot, doesn't it? For that little £2 coin to have 633 millimeters squared. But if you really look at a millimeter squared, it's a square where the length is a millimeter. That's that little gap on a normal ruler. That's very small. So it's surprising how small things add up, isn't it? So that's the large one, and then the small one, we're at the radius of the center circle. So we've got that, that's useful. The area of the inner circle, we'll call it, is equal to So it says the radius is 10.65, so that's useful. And on a calculator, we'll do 10.65 squared equals, and then times shift pi. Eek. Okay, 45369 over 400 pi. For the decimal fans in the world, it's about 356.327 blah 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 millimeters squared. Okay, so we could see one is obviously bigger than the other. That makes sense, and the difference between them is going to give us our answer. Now, in my opinion, the best thing to do is to keep that last answer on our calculator and straight away write, let's see if this will get us, write this into our calculator. So I'm just going to press the fraction button, 5041. Keep it on the top so I'm sure it's going to do it correctly. So 5041 times pi, and on the bottom the denominator 25, and I'm going to move to the right of that fraction, and I'm going to take away the answer, which was this over here, because that's what's stored in there for the last thing. And then I don't really need to do much retyping in. It's really useful. I'm going to say the area. Don't write with a highlighter, that will not be useful. I'm going to say the area of the large, take away the area of the inner, is equal to 35,287 over 400 pi. But you can write that, you can leave it as it is, because that's exact. But if you're asked to do it to a certain decimal place, you're going to need to press that button to change it to something like this. And I will write the answer, it's 1434499, but I'll write it as 14 millimeters squared, and that's rounded to 2 decimal places. It's always courtesy to show what you rounded it to. And we're done. We've found the area of the brass section. In fact, this here, yeah, no, I won't go into that. Let's move on. So a pendulum on a large grandfather clock. This is something of the yesteryear. Swings on a rod that is 74 centimeters long, so it's bigger than it looks. A little mini mathematical diagram on the right here, which helps us visualize what is going on. And through, it also swings through an angle of 15 degrees. Right, so back, forth, back, forth. And what distance does the tip of the rod travel on each swing? Oh my goodness, I thought that was going to say per minute. That's going to be this is a more difficult question. But yeah, just simply in one swing. So essentially, we're trying to find this red bit here, which, if we didn't know, it's part of a circle, right? Anything that is fixed to a point here and moves around is going to create a circle. I'll just do it and undo it like this, right? It's going to create a circle. Essentially, it's part of that circle that we're moving. Question is, what part of that circle are we moving? Like, the circumference goes all the way around, but it's this much of the total. 15 degrees represents a part of the circle which has 360 in total. So we could say this is the fraction that it moves around. So we say of the total circumference. Now obviously A-level, if you're watching this thinking, oh, that's just watching this for fun, you've got better ways of doing this in radians. But this is the fraction method. So it seems to me as if we need to find this total to circumference. And if we got this phrase here, it means multiply. So we got 15 out of 360 multiplied by total circumference. Do we have enough to find the total circumference? So circumference is equal to, and that's total circumference, pi, yeah, we know that, it's a number, times diameter. Well, if this is a radius, we just times that by 2. So that's 148. And that's going to be in centimeters. So the total is 148 pi. See how easier that is if you don't want to find the decimal? But if you do like the decimal, that's what I'm here for. I can write it for you. 464.955. And you see the decimal at some point, you're going to cut it off and lose accuracy. So you tell me what you're going to use. Aspire for the top, I'd say. Don't forget centimeters. Where are we at with this question? Thankfully, I've made myself a plan at the top, so I can always go back to it and see where I am. Okay, so this bit's done. This bit I found is a multiply, and the total circumference is 148 pi. But I want this fraction of it. So if I want a fraction of a number, I just multiply by that. So taking what's already on the calculator, multiply it by 15, divide it by 360, and I find that the answer is 37/6 pi, which is in centimeters. It looks a bit odd, but if we put it into decimal, it seems reasonable. 19.37 centimeters to 2 decimal places. So that's the distance of this arc that's in red there. It's all about the fraction, and you find it from the degrees. Okay. Are there any more questions down here? Let's double check. Ah, good. Let's go to the top. And across we go. This is actually a real place, by the way, in England. And it's a 5-star attraction. You should look it up. It's called the Hole in the Wall. And like literally a hole in the wall could be like a bank thing where you get money out, but no, this is literally a hole in the brick wall right beside a cash point. And it's got some rave reviews. Anyway, I thought I'd use it as inspiration. Due to the popularity of the local hole in the wall, a neighbouring bank wishes to have their own booster recognition. So basically, it's made this bank famous. How much concrete would be needed to create one that's using the dimensions below? If the diameter of the hole needs to be 80 centimeters and the slant of the wall is 30 degrees. Goodness me. So there's a few things in here that we might want to figure out. Firstly, we're dealing with prisms, clearly. What shape is the wall? By the looks of it, it's a right trapezium. So we've got our we've got the A and B at the top, which are the parallel sides of the trapezium. We've got our height, which is 190 centimeters. Don't worry about the depth for now. That's to find the volume, but we want to find the area. And that's not right on that, but I will do this instead around the outside. Let's go for red. We want to find the area of this, which is the cross section of the prism. Because once we find this as a 2D area, we can multiply it by the depth. So I'm recognizing the trapezium, so we can use that formula. So that, look at me using that again. So the area of the trapezium, cross section, that's a bit of a mouthful, but hey, is a half, and there's a lot of ways of writing this, so if you have a different formula, go with that one, but this is one version. We're going to multiply all those three together, so we need to find B. Now, of course, it isn't that straightforward, and we might need to employ, I think here, yeah, so this is a right angled triangle, and we might need a bit of trigonometry. So this would be the opposite of the angle, this would be the adjacent, and this here would be the hypotenuse. And do we have the adjacent? Yes, it's 190, because it's the same as the height over here. And so we're dealing with A and O, that's tan. So a real quick calculation, tan of 30 is equal to the opposite, which is what we want, over the adjacent, which is 190. That's not 0, by the way. Let's write op, just so we know. In fact, let's do it on a new line, because we're not equating. So that's 190 times tan 30. It's going to give us the opposite, which is the missing gap that we have to find the length of b, because it's going to be 310 subtract the opposite value. So 10, 30 is like root 3 over 3 multiplied by 190 is, I wonder if we can get that actually in exact form. So 190 times root 3 over 3, and 190, that divided by 3 nicely? No. So I'm going to leave it like this. I'm going to leave it as, what would look the best? 190 root 3 over 3, something like that. Like it's in centimeters. And if you want that as a decimal, 190 divided by 3, no, I'm going to do it a different way, times root 3 divided by 3. That's 109. I'm going to put approximately 109 centimeters difference. It's fairly big. But I'm going to use the exact form to do this. So 310 subtract, I'm going to put in brackets to be extra careful that I wanted to do it in this order, 190 times root 3 all over 3 in brackets, boom. Okay, so again, we don't have the exact form. We have this decimal, so it might be worthwhile changing to decimals and using loads of decimals. Alternatively, we could work with this written into the calculator. So that's what I'm going to do, because we now need to put this into the formula, because we just found b. And let's write it out again. Area of the trapezium cross section equals a half times a, that's easy enough, 310 plus the answer to that. In fact, that isn't that, is it? That's just the opposite. It's the subtraction that we're looking for. So it's plus the b side, which is 310 subtract the 190 root 3 all over 3, if you follow, and times by h, which is 100, and I think we'll put a dot actually just to signify multiplication, which is 190. Take a moment to see if you know where that came from. I'll just highlight once and go through. Oh, it's very small. Make it, oh, that's why. Let me change it to a highlighter. A bit bigger. Right, so this is the half, and this is the a. This, what we have to yellow. This here is the value of b, because it was 310 subtract the answer to what the opposite was. And lastly, we have h, which is 190. Okay, so a good little bit of color coding there has helped sort out where things have gone in terms of substitution. And the last step is to multiply that all together. So that's that. I'm going to plus 310 and divide it by 2, because times it by half is the same as dividing by 2, and then I'm going to multiply 190. I get something rather monstrous. So I'm just going to write it out like 48,478.82 ... and that's in centimeters. That's an area squared. And then I go to multiply that by 42. I'm just going to scroll down. So we're going to get volume of the wall without the hole is equal to this number here, 48,478.82 ... multiplied by the depth, which is 42. So I keep it on my calculator, and we get this whopper, 203,611.761. I'm going to leave it as many decimal places I can see on my calculator, and it does actually stop there, so we'll go with that. Could have used like exact numbers up here, but this is what I'm being presented with. So volume in total, we now need to take away this sort of hole. As you can see, we're dealing with prisms, and this is no exception. This is a cylinder, which is a circular prism. Circular prism is going to be dealt with just like we did the other one. We're going to find the area of the cross section, in this case it's a circle, and then we're going to multiply it by the depth, which is also 72. So what should we call it? We'll call it area of hole. This is the cross section. It's going to be equal to pi r squared, which we're dealing with earlier, so no need to be shy on that one. And it does say that the diameter of the hole is 80 centimeters. We want radius, so we'll divide that by 2. So we've got pi times 40 squared. This is going to be in centimeters, so be aware, centimeters squared. And if we're being really good, we will just write this in terms of pi, or in fact easy and saving time as well. Remind ourselves that this is the area of the hole, and then to find the volume of the hole, we're going to multiply that by the depth again, which is 42, because this one goes all the way through. It has a depth of 42. That's 67200 pi centimeters cubed, because it's now a volume. I think I made that mistake earlier up here. We're going to change it to centimeters cubed. Well, how did even millimeters come in? I think my head's in the previous question still. And this is why we always double check, right? Does it make sense? Are we doing it? All right. And the final thing is to realize that the volume of stuff that we need to make this thing is going to be the overall block. And then we're going to take away that cylinder. So we've got these two values. And I'm going to keep this one on my calculator. And I'm going to type in this one. So the, what does the question say? Let's phrase it in that way. How much concrete? Okay, so it's going to be like the volume of the concrete. And so the volume of concrete needed is going to be 2036110. Like that. Put it in my calculator ready. Subtract the 67200 pi so subtract answer, and we finally have 1824995.74. I'm going to round it to 2 decimal places, and that's centimeters cubed rounded to 2 decimal places. I may have got something slightly different than me, and that's fine, because there may have been some difference in rounding, but like not the end of the world if you did. Okay, oops, pressing buttons here and wrong things coming up. Take a moment to think about that one while I just change screen. Okay, that should be good now. All right, so next question, unless there's any more. Let's just double check I didn't put another one. No, that's good. Love this question. I never got to visit this hole in the wall. If anyone does, let me know. All right, a mold used to create a toy house is shown below. So actually this is empty, this is hollow. And it's going to be filled with a rubber substance. So it's going to be totally solid shape to make a composite shape of a cube, which is on top. And the special properties of cubes you need to be aware of, and that's why it says the word cube. And a right square based pyramid. Well, a right square based pyramid means that the center of the pyramid, the tip, is right in the middle of that square. Okay, find the volume of this shape and you may find this formula useful. Okay, so what is that? Did you recognize it? Length times width times height. It's definitely not a cube, is it? So that's pyramids but with an I. It's going to be an A. Never mind. Let's start with the top bit, the cube. Yes, a cube, the most important fact is all sides are the same, all edges are the same, meaning we can find the volume quite easily. It's going to be 8 times 8 times 8, and I mean we could leave it as that, but we can just write in what are we in centimeters. Centimeters cubed. Okay, that's not too bad. So we're looking at volume of basic shape there, which is technically also a prism, but hey. And it's to be filled with this. So we've now got the pyramid on the bottom. And the question here is, how do we find what we need to figure this problem? Because it doesn't seem to give us what we have in here, right? So we can write this out fully so you can see this is a volume of a pyramid, and it's going to be length of the base, by the way, times width of the base multiplied by the height. In fact, we're going to call that perpendicular height of the pyramid from the base to the tip. Or that's not good. Let's do this. I think what it does, it recognize. Yeah, see, it's gone red. It's recognized that that's a key point, but I wish I could tell it to ignore that. And that's going to be all over 3. One of the most fascinating things about pyramids is that they are a third of the cube that surrounds them. So if that pyramid was in a box, which was exactly the dimensions of its base and height, then it would be taking up exactly a third of the volume inside. It works for all polygon-based pyramid things, all the way up to infinite sides, which we might call a cone. So that's kind of nice. That's how we recognize what formula that is. But I think the thing we don't have, that you've figured out, is this perpendicular height. Let's just be clear what we have so far. Let's move to a pen, might be nice. We have a length of the base, okay? So the base is given by the fact that this is a cube. So the length of the base is 8 and the width of the base is 8. So that's not too bad. The height is from here to here. And the only other bit of information we'll be given is this. If I draw from the diagonal to the center, I can see a right triangle. So it might be useful here to employ this. Probably not going from the side, or could we go from the side? I suppose we could go from the side. Going this way is going to take a little bit longer because you've got to go here first, which is going to be a 4 by 4. And then that Pythagoras base on that. Could we go and say that, would that save us time? 4 and 4. Yeah, probably. But we'll go from go from the center and do a diagonal because it's more interesting. If we're going to go to that center point, we're obviously using half of the 8. And so we're going to split now the top of the cube, or bottom, depending on how you look at it, in halves and use some bit of 3D Pythagoras. So 4, and if we draw this triangle out, we can see that that's 4 and that's 4. This triangle is this one here. Okay, it's like the base. And what's the point of this? It's to find the hypotenuse, this one here, which is the base of this. And so, we'll keep it in red. We'll keep it in red. X is equal to the square root of 16 plus 16. So that's the square root of 32. Also known as root 16 times root 2, which is 4 root 2. So that's the length of the diagonal there, 4 root 2. And if we now focus on the triangle that goes across there and up to the height, we could draw another triangle just to visualize that. This is the height of the pyramid, is what we're looking for. And we just found that the base of it is 4 root 2. And then we've got the diagonal length there, which is the hypotenuse, because it's opposite opposite the 90 degree. It's a way to tell. So we've got a little slightly different calculation here. We've got 4 squared, take away the 4 root 2 squared, square rooted is equal to h. And we'll work it through. That's going to be the square root of 16, subtract, and we're going to get rid of that. So it's going to be 16 times 2, which is 32. And that equals h. And 16, wait, hold on, is that correct? That must be more. Hold on, what's going on here? That's 8, 8, so 4 across and 4 in. That's certainly correct. Is that that's the right angle there, so that would be 16 versus root 32, which is 4 root 2. Good. So that's this is essentially slightly more than 4, and it makes sense because that's the hypotenuse. And the question here is this 4. That goes across there and creates a right angle with a tip, and we're looking for the h. So 4 root 4 goes across there. Oh, that is odd. I suppose this question here might be... I think I know what's going on with this question. This question here is it's created a shape that perhaps it doesn't quite work. Or should it, based on this 4? The question is it possible to have a shape like this? Let's try and use a bit of logic here. If this side length here was 4 centimeters, would this shape even be possible? What a great discussion. Well, we've just proven that the diagonal here from, let's draw the square so we can see what's going on. This is the bottom of the cube. We've just proven that this diagonal is 4 root 2. Now if we wait, was it 4 root 2? Yeah. So if we do 4 times root 2, well, that's 5.65. And if this slanted edge here were to be raised upwards, at the very minimum, it needs to be 4 root 2 if it's flat against that cube, you see? Because then it would be the same and it won't be elevated. In fact, this number here needs to be bigger than 5.65. Otherwise, that shape is not going to be raised above. And therefore, when we have this triangle over here, we've created a problem that doesn't work. Now I'll show you what happens when a problem doesn't work, and it's good to recognize this and know what's going on. H equals the square root of negative 16. Ooh, well, in fact, when you get to it, this is 16 times root 1. And at A level, we talk about a solution which is imaginary. But for you at GCSE, this will create an error. So I do like these sort of things when they come up, because we can discuss them. So you start getting errors and you know you've done something wrong. Or let's just say the exam question was like wrong. So being the examiner that I am, all we need to do is adapt this question in the moment and change it to something slightly bigger. So as long as it's above 5.65, I think this is going to work out jolly well. I don't know, there's going to be a nice number, of course, but it must be at least 4 root 2. So let's go again. And so we've got our triangle, our height there, and we found our 4 root 2. This is now 8. Our h is going to be the square root of 8 squared this time, which is the long side to subtract 4 root 2 all squared. And let's scroll down a bit, give us some space. 64 subtract 16 times 2, which is 32. Much better. Oh, look, we're back at root 32. Hugh knew. Lovely isosceles triangle by the looks of it. Perhaps I should have known that. Perhaps there's a way of proving that, but we probably want to simplify this. This is a process called surds. They will be coming up later, but we may as well see it now. So the height is 4 root 2. Really useful. We can go back to our original formula now and write in 4 root 2. And what do we get? I think we'll switch back to blue. See if we can sneak it in at the end here. 8 times 8 times, put it in brackets, 4 times root 2. Then divided by 3. And yeah, let's try and sneak it in. You know where it is. 120.679 ... And this is a volume, so we're going to be writing centimeters cubed. Now, that's not the end of the question, is it? We have to find the volume of this. Look, the volume. Okay, so typos, 2 of them in this question. Must have been a late night. Find the volume of this shape, which is going to be, highlighter at the ready, this here, plus the volume of the cube, which is this here. So I'm going to keep that on my calculator and add 512 to it. My final answer, I'm going to write down the bottom. Total volume equals 632.68 centimeters cubed. I rounded that to 2d.p. 2d.p. Okay. Sounds like a Queen song. Yep, we're done. Find the volume of the shape. It was hard won. But this can happen. Sometimes we choose the wrong number, like we read the question wrong. We're panicking. We read it from somewhere. And when we work it through, it's wrong. And that's a good indication that maybe we need to check that we've read something wrong. Alrighty then, let's move on. Golly, look at this. Never seen this before. A tool will be used to drill a cone-shaped hole in the wooden hemisphere, exactly equal to the dimensions of the drill bit. So this here be the drill bit. It's a cone. And it's going to make a cone-shaped hole in this hemisphere, half of a sphere. The original sphere had a volume of 926.5 centimeters cubed, used for, we could probably highlight this as we go along. So the sphere had a volume this, and the length of the drill bit from the tip to the base is 4 centimeters at the diameter. And so hold on, what does it say? The length of the drill bit from the base to the tip is 4 centimeters. Let's label that as we go. So this be the length, 4 centimeters, and the diameter at the base is 3.2. So maybe we should draw it separately. So the diameter at the base, 3.2 centimeters, 4 centimeters, and that's our lovely cone, or gnome hat. Find the volume of the wooden shape after drilling. Okay, so this drill is going to go down and remove some volume out of this hemisphere like this, okay? And this is that cone shape. So it'd be nice to know the volume of that cone. And it's always nice to know the volume of that shape. But it came from a sphere. So we look over here on the right. Which one is the volume of a sphere? If you pick this one, then you be correct, because this top one is actually the volume of a cone. You see, it's pi r squared h, which is a cylinder, and the cone will always take up a third of the cylinder that surrounds it. So this will be the cone, like that. So let's go for the sphere first. The sphere information that we have is that the volume is 926.5 centimeters cubed. So that's actually not that hard to know, like what to do with. It's literally half of that, right? So 926.5 divided by 2. So we have that the volume of the hemisphere is 463.25, and what we're working in centimeters cubed. The length of the drill bit. So now we need to find the volume of the cone. I think half the battle in all of these is just knowing what to do, isn't it? So we can read and get on with some of the formula. We're pretty all right. So the volume of the cone is going to be, I like to write it like this. So pi r squared h. So let's put all of that in. The radius, that's what we want to know. That's 1.6. Okay, so that's half of the diameter. 1.6. I'll just write it on the diagram so you can see. Squared times the height. Oh, the height of the cone was 4. Okay, let's be careful writing this in. I'm going to do 1.6 squared equals times 4 times shift pi, not times, divide by 3. And we get this perfect fraction, which we don't want to disturb too much. That's pi, so volume, so centimeters cubed, or we can write as a decimal, which is 10.723 ... I always get these numbers. I don't know if I've got a bias in me that I'm not understanding, but it's always 0.723. I think I made a question just the other day with those. They come up a lot. I need to investigate what that is as a fraction. 723 thousandths. Well, that's not that. I wonder if there's a reason for it. Anyway, here we are, 10.723 ... I'm going to keep it in the calculator, or I'm going to write it all out so I don't need to do the calculation again. But those of you that love the decimals, there you have it. What is the aim of this question again? The sphere of the... yes, we've got half of that. Now we just need to subtract the cone, don't we? Volume of the wooden shape after the drilling. I think that's it, really. So one of these formula were a dud. I think there's scope here for a second part of the question. Yeah. So how could we make this question harder? We could say that the radius of the sphere was the diameter of the base of, it'd be a huge drill bit, but if that was the case, we'd have to use the volume of it. Let's do that in a second. I'll show you how that works. So so what we're going to do, say the volume after is going to be the volume that we have currently, 463.25 centimeters cubed, subtract what we have up there in perfection form, centimeters cubed. So now that's on the calculator, I'm just simply going to write 463.25, yep, that's correct, subtract answer, and we get 452.5. Now it does want it as a decimal, so 0.53 centimeters cubed. Okay, so that's done. Ipso facto, thank you very much for the grade 9. Well, this won't be grade 9, maybe grade 8. And so we wanted to explore how this question might be a little bit harder. So bonus question, bonus extension for those watching the live, thanks for being here, is let's say that the base of the drill bit was equal to the radius of the sphere. In that case, we would want to use this formula, which is, hello, anomaly. The volume, let's put sphere, equals 4/3 pi r cubed. And it was this, wasn't it? So 926.5. And our job, obviously, therefore, if the radius here was equal, sorry, the base of this cone was equal to the radius, we've got to find a radius. So quickly go over how you would divide this stuff. Like, there's so many ways, right? I'll just split the page. There's one way. You put 926 in the calculator, 0.5, 926. And then we're going to rearrange it in our head based on this, right? So we're going to do the opposite. So my first step would be to, and I'll highlight as I do it, multiply by 3, press equals, and then I'm going to divide it by 4. So I'm doing the opposite in the opposite way of bid mass. I've got to know my bid mass. And then I'm going to divide by shift pi. And then to get rid of this cubed, I'm going to cube root. So a few little bits involved in that, but there is a button for cube rooting. It's actually a dedicated button, but you can do your own. And when you cube root it, you get straight, look at me using that again, fool of a talk. When you cube root this, finally, like the answer, radius should be 6.047635. Okay, and then you would use that as the diameter of this base, and then you'd half that, and it would go into the formula here. And then you carry on, and then it would be a jolly good question. Obviously a little bit harder, but we're in the early stages of the revision here, so we're not doing anything too crazy. So anyway, you want to use the full decimal place until the final answer. The other way of doing it is do it like properly, and I'll just go through that to show what it looks like if you wanted to write it down. You could deal with this first, and if you treat all of this as one thing multiplying the r cubed, we could say r cubed equals 926.5 all over 4/3 pi. That's just a number on the bottom, but I just can't be bothered to work it out, right? You know what I mean? Don't have to. It's kind of a waste of our time until we get to the end. And then we have to do the cube root. So what it looks like is the cube root of, leave space, 9, all of this up here. Hopefully this works for me. E. And then that goes in the calculator, and you'll get the same as you got up there. R equals 6.047635, etc. And that will go back into the question. What a cool extension, eh? So that's a possibility. As you can see, we can handle it. We can put it equal to 926 and rearrange the formula. So from this point onwards, we will need the skills of rearranging formulae, and that's going to be our next lesson. So I've already created that. I'm going to put the questions up on Patreon now, because I usually give you like a few days to do it, but I'm going to give you a whole week. So after this has gone live, in about half an hour, look for the next week's questions, which are surrounding algebra. So first look at algebra and solving equations on one level. I think we're going to do 3 levels of algebra because it's so important. So looking forward to see you there next week. And yeah, thanks for sticking around. I don't see any questions in the live chat, but I usually get people looking at this video when they want to, which usually isn't live. But this is the time that we're all possibly awake together. So hey, have a good week, and I'll see you in the next one.